Last time, we demonstrated how downward refraction can cause a boat to appear to sink as it travels out into the horizon across a flat plane. Since then, a globe earther on our debate board by the name of Vimal Ramachandran has presented a video supporting a rivaling claim. Here we have a stack of different colors of clay on a paint can. Now the camera is going to go and be placed behind a curved surface, with only the top color being visible. Let's zoom in on that. Okay, now only the top color is visible. Now watch what happens as he pours liquid nitrogen onto that canister in front of us in order to create downward refraction in the air. See the red? Downward refraction here is extending our range of view, allowing us to see that red color that we wouldn't have been able to see otherwise. So here we have our two rivaling observations. Across a flat plane, we can observe how downward refraction limits our range of view and causes objects to appear to sink as they travel farther away from us. On the other hand, however, across a curved surface, downward refraction can extend our range of view and allow us to see things that we normally wouldn't be able to see. So the question is, what is going on here when we see images like this one of the Chicago skyline from about 60 miles away? If the Earth were a globe, that would be hidden under nearly 2,000 feet of curvature. So what's going on? Is our range of vision being extended around a curve because there is more refraction in the air? Or is it being extended across a flat plane because there is less refraction in the air? It's kind of hard to tell by just looking at this picture alone. It might be easier to tell if we had something to compare it to. Kind of like how we did in our last video where we compared our two images of the boat on the horizon. Thankfully, Joshua Nowicki, the guy who took this photo, took a bunch of different photos of Chicago at different times of the year, giving us plenty to compare it to. Here on his Facebook page, Joshua shared a much more limited view of Chicago taken this last February on an obviously refracted day. Is refraction extending our range of view here, or is it limiting it? Here's some footage that he took last March and shared on his YouTube channel. I think this one that he took on his Facebook page of Chicago at night is pretty cool. Now here's some footage that he took in April of 2020. Here, let me zoom in on that for you. You definitely can't say that seeing Chicago from 50 to 60 miles away is a cherry-picked occurrence when there's tons and tons of footage on it. Here's April of 2015. Watch how these buildings appear to rise and fall. Here's another one from April of 2015. It's kind of faint there. And people wonder why you can't see England from New York. This is called atmospheric opacity. I think this video he took in May of 2015 is his best one. I also think it's the least distorted out of all of them. Here I'm not seeing any heat haze, and I'm not seeing the buildings get stretched up and scrunched down. That is pretty strong evidence that we are seeing more because there is less refraction in the air, not more of it. Now here we are in September of 2019. Let's watch this. Whoa, hold on, let me pause that. Look at that. That looks like this kind of refraction going on there. That's upward refraction. Good luck with that one, globe earthers. Now just look at these little tiny buildings seemingly just floating in the air. And here we are in October of 2015 with another seemingly floating building. Alright, well, I think I've showed you enough to help you see that seeing Chicago from 50 and 60 miles away is not a rare occurrence. And hopefully this helps you see that since you can see varying amounts of Chicago depending on the weather, you can't just blankly point to a boat appearing to sink on the horizon and say, "Oh look, that proves the Earth is a globe." You have to take the atmosphere into account. If the atmosphere can make a city appear to sink on the horizon, it can make a boat appear to sink on the horizon. Thank you all for watching.